last two posters were going to be introduced by our good friend and our BJ's colleague, Paul Wilkinson. Now, unfortunately, Paul's been feeling a bit unwell and was unfit to travel this week, so he can't be here, but fortunately, you'll be pleased to hear he's fine and he's already looking forward to the next Gelmon. He sends his warmest regards to you. The bad news is you've got me instead, so I'm going to try and introduce these two posters on his behalf. The first one up is called 4D Inversion for Automated Near Real-Time ERT Monitoring Applications. And the idea, thanks, yeah, if you can just forward for me, please, that's great. So the idea is really, imagine you have an ERT monitoring array and you're collecting regular monitoring data, and you're really interested in having sort of near real-time information. So you've got to put some spatial and temporal constraints on your inversion. And really you've got two options. I mean, Myung-Jung's explained it very nicely, so I don't have to go into too much detail here. It's essentially conventional sequential time-lapse inversion is quite well suited for that, because as you collect each new data set, you can then basically constrain it either to a previous data set, or you can do difference inversions or whatever. So that is quite well suited for real-time use. We have, again, already heard in Myung-Jung's presentation that full 4D inversion has got its advantages. So if you put full spatial and temporal constraints across the entire data set, then that's got a number of advantages, such as, for example, you can account for changes in the subsurface during the acquisition of the data, and also you're getting rid of basically the dependence from a baseline, or sort of the time directionality that you sometimes get in conventional time-lapse inversion. So other features such as the accounting for noise or missing data and the changes caused by that are basically accounted for by both types of strategies, and likewise both reduce artifacts and non-uniqueness. But there are certain aspects of 4D inversion which are advantageous, so we'd like to use it, but the big disadvantage, or the big catch here is 4D inversion, of course, operates on all time steps simultaneously. So it's apparently not well suited for obtaining near real-time information if you're doing monitoring, okay? So imagine you have a sharp event in time, like sort of rainfall event, or some other sharp change that you'd like to sort of constrain your 4D inversion, then you really need information from far into the future in order to get a reasonably well constrained data set. And so that doesn't apparently seem suited for real-time information. So the solution is to use a rolling short time window for your 4D inversions. So essentially, rather than inverting the full sequence, you just invert a subset of the data with the full 4D constraints. And you can see here a little comparison of, I think this is Cornelia's leak experiment, where you have the comparison between individual inversions here. You have the full 4D sequence, basically inverted with all the data sets, and then you have, by comparison, if you like, inversions just over a 3 time step window here and over a 5 time step window. And you can see that the 3 time step window reduces differences relative to the full sequence inversion by a worthwhile amount, and the 5 time step one doesn't improve it much more. So we feel the 3 time step one is a good alternative, and these differences, or the way the differences are reduced to a similar level to those caused by the baseline or time direction dependence in sequential time-lapse inversion. So overall, that seems like a good strategy, and there are some examples on the poster. So thank you for that.